Reactions of alcohols and hydrohalic acids. Hydroxyl group is a poor leaving group. Protonating this, it becomes water, which is an excellent leaving group. From there, it can undergo SN1 or SN2 reaction mechanisms to give a halide. I'll go over both the SN1 first. Whether it undergoes SN1 or SN2 is going to depend on the structure. In this situation, there's a tertiary alcohol. SN2 is unlikely because SN2 requires a backside attack of the carbon, and if it's tertiary alcohol, then the backside of the carbon is very blocked up by the other groups. So therefore, SN1 takes place. This gets protonated, SN1 reaction mechanism occurs, this leaving a carbocation. The halide ion comes in, and we're left with this. Simple enough. The SN2 is protonated as well, just like in the SN1, but here the halide ion attacks the backside of the carbon. In this primary alcohol, it's much more exposed. The SN1 reaction mechanism can take place as well, but if you just look at this requires a carbocation, so it's more unstable and less likely to occur. Of course, it depends on what's going on, but more often than not, particularly with primary alcohols, the SN2 reaction is going to take place. With secondary alcohols, I guess it depends on how stabilized that carbocation can be, but generally, this is going to have a lower energy than forming a carbocation. Most of the time the SN2 will occur, but anyways, it just attacks the backside of the carbon, it leaves, stereochemistry changes, just like any other SN2 reaction. A couple of notes on here. Firstly, there are generally poor yields of primary and second degree alcohols when using chloride. 2. Elimination reactions can occur. So depending on what exactly the nature of what we're trying to accomplish is, this may be a potential side reaction that can occur. 3. Rearrangements can occur. Of course, this all depends on the structure. This is just some very general ideas when we're doing reactions, just to keep in mind. This may look like a good mechanism, but depending on what the other groups are out there, we need to keep in mind this sort of thing. And 4. Reacts poorly with iodine.